And welcome to the Smash News Network, least busted name in news. We're looking at the magnetohydrodynamic pressure around planet Earth, Earth's magnetic moment from space. As modeled by the Space Weather Modeling Framework, it should show us the last 4 hours. Modeled in nanopascals, again, magnetohydrodynamic pressure, giving us insight into the plasma environment, Earth's magnetic field structure, and more. It's the Geospace Magnetosphere movie. And we show it daily on the channel. We've been putting our videos in various spots, and it has to do with algorithmic thumbs on scales. Next, looking at the GOES magnetometer here. And I would cite the details tab for the GOES magnetometers page if you haven't read that. It's quite interesting. It explains some of what we regularly show on the Geospace Magnetosphere movies. For example, if the data drop to near zero or less when the satellite is on the day side, it may be due to a compression of the Earth's magnetopause in the geosynchronous orbit boundaries, exposing satellites to negative and or highly variable magnetic fields. So on any of these Space Weather Prediction Center applets, check out the details tab if you don't understand the data that you're looking at. That's the GOES magnetometers measured by the GOES 16 and 17 over the past 3 days. Seeing a very low reading there. There is a coronal hole high-speed stream showing up here. It's pretty weak at the moment. We'll cover it momentarily. First, Earth's magnetic moment from the ground. This one's modeled in nanotesla magnetic flux density. It's great at showing the locations where we would see induction into power systems, pipelines, railways, the aurora. At the moment, not a lot of that going on. Not a lot of changes to Earth's B field geospace delta B going on currently. Next, we'll go to the real-time solar wind. Oopsies. Let's move that back up. There we go. I apologize for that temporary aside. And here is the current state of affairs. We've actually seen a dip here in the past hour. Current conditions are only 363 kilometers per second for the solar wind speed, solar wind density 7.62. 7.62. Are we seeing calibers here? All right, so anyway, it's looking like another rather weak coronal hole stream here, folks. It only made it up to about 400 kilometers per second. So this isn't in full effect yet, so we can expect a significant downtick in the solar wind density and a significant uptick in the solar wind speed. Looks like a weak series of coronal mass ejection strikes here also occurred yesterday. See some pretty wild fluctuations there in both the density and the pressure, the density and the velocity rather, and the temperature. So that looks like a little CME strike there. Quite minor, didn't really cause any sort of geomagnetic effects. Now we see the South Pole current sheet rushing our way. As we forecasted yesterday, has to do with understanding the magnetohydrodynamics, I guess. And you can see this South Pole current sheet suddenly rushing toward Earth, shown there in red, right there in the last few frames. That is the arrival of Sunspot 2975. So if you look at this at the magnetogram from the line of sight view, you can see this very significant magnetic region up here, and that's Sunspot 2975. It's recently become, in the last 24 hours, it's become the most interesting portion of the Earth-facing solar disk. Next, the coronal hole line of sight plot showing the sun's B field in blue. Some South Pole-oriented coronal holes rotating in here as well, south of Sunspot 2975. And we can expect a coronal hole high-speed stream, possibly some geomagnetic unrest late tonight on the 23rd, early into tomorrow on the 24th. According to the NOAA forecast, a high-speed coronal hole stream is on the way. Next, looking at coronal holes through the 193 angstroms wavelength here from the SDO. What the heck happened? There we go. There's 193 angstroms from the SDO. And you can see these two well-defined coronal holes here, right near the equator. Those are both North Pole-oriented coronal holes. And again, we're expecting a little bit of an intensification. We may see some aurorae tonight. Make sure you follow us on Twitter. Oh, I apologize. That was yesterday. There's today's view. So there's the last 24 hours from when we recorded the video approximately. There are those coronal holes. They've actually gotten a little more defined here. Remember, folks, the solar corona is very bumpy. Sometimes there are coronal holes that are not visible due to plasma. So this area right here is hiding these South Pole oriented coronal holes over here are being hidden by a bunch of plasma there. There are indeed coronal holes there, as we showed in this imagery. Anyway, now moving on to sunspots. Again, sunspot 2974 is the second most interesting area. Sunspot 2975, very interesting, quite large. The trailing umbra is like larger than the Earth. So here's a full disk view in 1700 angstroms, part of the ultraviolet electromagnetic radiation spectrum. Ultraviolet light there. And let's move in a little bit closer to get a better view of sunspot 2974. So here's 2974. Looks like it's been mostly stable. It's actually degraded a bit here over the past 24 hours. So we can expect the South Pole current sheet to be here by the time we make tomorrow's video. We can expect Earth to be in a South Pole heliospheric current sheet. And it's mainly a result of both the degradation of sunspot 2974 and possibly the growing of sunspot 2975. It certainly has grown. We can see the leading umbrae there actually gaining some umbral area over the past 24 hours. Great view there of the evolution. So that sunspot is growing as it rotates in, making it all the more interesting. You can see the size of that trailing umbra there, that South Pole umbra there behind those growing leading umbra. Much larger than planet Earth there. You can see the Earth scale. Keep in mind those are still very far away, as the sun is quite large. A great wavelength to view X-ray flares, solar flares, is 94 angstroms. We did see some C-class intensification since yesterday, and you can see those brightenings from both sunspot 2974 and sunspot 2975. And we pride ourselves on creating some of the best content, the best solar imagery, and the most in-depth daily space weather on the internet. So here's the flaring profile over the past 3 days. Again, only a few C-class intensifications. What I would note here is that we're getting toward a C-class background level. We're almost at the point where we are seeing just a regular everyday C-class X-ray output without flares. So we came all the way down to a low B-class here, and now we're going right back up. And it looks like we're seeing a Terminator event, folks. Yeah, a Terminator event. We're going to have to make a video about that. We're trying to get Scott McIntosh on the channel. Shout out to Scott McIntosh and Tamitha Skov. Rather, Tamitha Skov, I believe, is the correct pronunciation. Let us know in the comments where the accent goes. Shout out to Tamitha. We'll be dropping you a line today about doing a video. So here's the proton flux returning to background levels here. No relativistic particles showing up from any of those C-class intensifications. And we see some radio blackout here. Some, at least radio brownout happening here over central Western Africa, caused by some flaring just while we did show prep, actually. So that was from the latest C-class flare there. Peak flux was at 9 o'clock universal time. Well, that was actually way back here. So additional flaring happening since that brownout. Anyway, that's the attenuation of the D region of the ionosphere. We talk about radio blackouts. That's where you can watch them. The deabsorption region predictions, or DRAP. Do you follow us on social media? Did you know we're on Facebook? Did you know their stock has crashed as we forecasted a year ago? Did you know we're on Twitter? We've only got 227 followers. Make an account. If you don't have an account on Twitter, you may see all kinds of additional material you're not aware of. If you enjoy the content, press like and subscribe on YouTube. press the notification bell. Who knows if you'll be notified? I really, frankly, have no idea. We get complaints regularly about people not receiving notifications or seeing the videos in their feed. We also regularly stream live to Twitch. This video was a recorded video. Today's meteorology segment will be streamed live to Twitch. Chances are by the time you see this, it'll already be a thing you can watch at twitch.tv/SmashOmash. We're also on BitChute. Thanks to our subscribers over there. And look at the view count on BitChute. Getting 2,000 plus views per day over on BitChute, and getting like barely 100 views per day on YouTube. I'm sure it's just a coincidence, folks. I'm sure it's not some sort of algorithmic nonsense, as the ultimate space weather coverage not recommended by YouTube. So pretty ridiculous. And one of the reasons we've created smashomash.com/SmashTeam is because of big tech. We discovered we needed our own websites back in 2019, so we created smashomash.com, and then we replaced Patreon with our own subscription services site, smashomash.com/SmashTeam. If you enjoy the content, consider sending us a couple bucks per month. By becoming a member of the Smash Team, you'll get additional information nobody else gets to see. Thanks to our YouTube subscribers for putting up with the pathetic censorship on the platform. Let's get back to some space weather data here. The KP index at 2. It's a measurement of global geomagnetism. The planetary K index. There it is over the past 3 days. We can expect to see this come up to a KP of 4, geomagnetic unrest conditions, according to the NOAA forecast, late tonight and early into tomorrow from a coronal hole high-speed stream. Here's a solar system forecast. There's the current state of affairs. We've got a gibbous waning for our lunar phase. Uranus is a very desolate place. It's quite far from the sun, and there are no other planets around there. Let's see what happens in a week. There's where things will be in a week, and oh my God, we've got like a line between Neptune and Jupiter and the moon and the Earth, which doesn't really mean very much at all. Let's look at a star chart. If you're up before dawn, you might see the moon. You might even see the moon at midday, depending on where you're located on planet Earth. But you might see Venus and Mars and Saturn and Mercury and Jupiter all rising ahead of the sun if you've got a low horizon and dark skies and it's clear enough and not cloudy. That's our all-sky chart from in-the-sky.org. And last but not least, we'll look at a coronal mass ejection that we saw yesterday, happening while we made the video, as we did do a live stream for space weather yesterday. A rare live stream, composite space weather video on YouTube. And it finally ejected, and it's expected to miss Earth well to the northwest. Looks nothing like an Earth-facing coronal mass ejection at all. It's on the far side of the sun. But there's a great view from Stereo A. The coronagraph located at Lagrangian point 5. And the Soho-Lascaux C3 over here on the right, located at Lagrangian point 1, in between the Earth and the Sun, about 1 million miles out toward the Sun. It's a gravitational equilibrium point which allows spacecraft to hang out there, orbiting that gravitational point without using a lot of fuel. So they can stay there for an extended period of time, like Stereo A does at Lagrange 5. And that's where we'll end our in-depth daily space weather video. Fields, features, sunspots, coronal holes, and more. Thanks for tuning in. Congratulations on realizing we exist. And may that solar wind be at your back.